Hello, today I will be teaching you what I've learned in Section 2. To start off, we'll be talking about double replacement reactions. A double replacement reaction occurs when the positive ions and the negative ions of two different compounds exchange places, forming two new compounds. In the demonstration equation, we'll be using barium chloride, sodium sulfate, and sodium chloride. This is the unbalanced equation. After balancing the equation, all we had to do was put a 2 before the Na. Next, we'll be talking about the periodic table. The periodic table is one of the most important tools in chemistry because it organizes all known elements in a systematic and meaningful way. The table was developed in 1869 by Dmitri Mendeleev. While the table did not exactly discover helium, it was later added to the noble gases portion of the table. Although because of the table's structure and the concept of periodicity, it contributed to its discovery. Next, I will be showing you the structure of an atom. This is a rough drawing. These would be considered hydrogen isotopes. An isotope is when each of two or more forms of the same element that contain equal numbers of protons but different numbers of neutrons in their nuclei, and hence different in relative atomic mass but not in chemical properties. A ion, however, is an atom or a group of atoms that have a net electric charge, either positive or negative, due to having gained or lost electrons. Now moving on to stoichiometry. Stoichiometry is the branch of chemistry that deals with the quantitative relationships between the reactants and the products in a balanced chemical equation. It allows chemists to calculate how much of each substance is needed or produced in a reaction. In cooking terms, stoichiometry can be compared to cooking in the kitchen. When following a recipe, the ingredients must be measured accurately to achieve a successful dish. Similarly, in chemistry, the coefficients in a balanced chemical equation indicate the proportions of reactants and products involved in the reaction. Next, we will talk about balancing a synthesis and a combustion reaction. For a synthesis reaction, the equation will consist of two simple elements used to combine and make a more complex element. So in this situation, after balancing the oxygen atoms and balancing the hydrogen atoms, we come out with H2O. Now for combustion reactions. Combustion reactions are a type of exothermic reaction where a substance, usually a hydrocarbon, reacts with oxygen gas to produce carbon dioxide and water, releasing energy in the form of light or heat. Combustion reactions are exothermic because they release energy. During combustion, chemical bonds in the reactants break and new bonds form in the products, releasing a significant amount of heat. Now we will balance this combustion reaction. After balancing the carbon atoms, the hydrogen atoms, and the oxygen atoms, this is the combustion reaction we are left with. Now we will move on to moles. In chemistry, a mole unit is used to measure the amount of substance. It represents a specific number of particles, typically atoms, molecules, or ions. In stoichiometry, moles are used to calculate the amount of reactants and products in a chemical reaction. Since chemical equations are balanced in terms of moles, the mole concept allows chemists to relate quantities of substances. The value of the mole was determined through the relationship between the atomic scale and the macroscopic scale. Chemists use the concept of Avogadro's number to link the mass of atoms or molecules to measurable quantities. Now we'll be talking about ionic and covalent bonds, which are two types of chemical bonds that form between atoms to achieve a stable electron configuration. Properties of ionic bonds include formed when electrons are transferred from one atom to another. They typically occur between a metal and nonmetal. The metal loses electrons to form a positively charged ion, while the nonmetal gains electrons to form a negatively charged ion. The resulting opposite charges attract, forming a strong electrostatic force. Now switching over to covalent bonds, which are formed when electrons are shared between atoms. They usually occur between two nonmetals, and the atoms achieve stability by sharing one or more pairs of electrons. Properties of ionic bonding. 1. They have high melting and boiling points. And 2. They conduct electricity when dissolved or melted. Properties of molecules with covalent bonding, however, have low melting and boiling points, and they are poor conductors of electricity. Now, we will be explaining this chemical equation using the concept of ions, catons, and valence electrons. So to start off, we need to know that aluminum is a metal with 3 valence electrons, and chlorine is a nonmetal with 7 valence electrons. Aluminum loses its 3 valence electrons to achieve a stable electron configuration, forming a caton with a charge of +3. Chlorine needs 1 electron to complete its octet. Each chlorine atom will gain 1 electron, forming an ion with a charge of -1. Now that we know aluminum has a +3 charge, while each chlorine has a -1 charge, to balance the charges, 3 chlorine ions are needed to neutralize the single aluminum ion. Now, to explain to Grandma Eliza how big an angstrom is. Imagine a single strand of your hair. You know how thin that is, right? Well, an angstrom is about 10 million times smaller than the width of one hair. To picture it another way, think about how a long piece of thread looks from across the room. Now shrink that thread until it's so tiny you can't see it anymore. Then shrink it 1,000,000 times smaller than that. That's about the size of an atom, and we measure those in angstrons. 1 angstrom is about 1/10,000,000th of a meter. If you stack 10 billion angstroms in a row, it would only be about the length of a yardstick. So while it might seem impossible to see or feel something that small, scientists use special tools like powerful microscopes to study them. Lastly, we'll be talking about enthalpy. Enthalpy is a concept in thermodynamics that represents the total heat content of a system. It includes both the internal energy of the system and the energy required to make room for the system pressure and volume. When you heat something, its enthalpy increases, and it releases heat when it cools down. Now let's compare a hot water bottle to a hot bread bottle. Water has a high specific heat capacity, meaning it can store more heat for the same temperature increase compared to most other materials. Bread, on the other hand, has a lower specific heat capacity compared to water, so it stores less heat at the same temperature. Therefore, at the given temperature, the hot water bottle holds more heat energy than the hot bread bottle, which will lead to more heat being transferred to you as the bottle cools down. So in conclusion, water stores more heat energy than bread at the same temperature. The hot water bottle releases more heat into the surrounding environment, which in this case is your covers, and keep you warmer for a longer period of time than the hot bread bottle. The enthalpy of the water bottle is higher, meaning it has more heat to give off as it cools down, making it the better option for staying warm at night. Thank you for watching.